Right. So the whole understanding which you need to have at the moment is there is a difference between true altitude and the indicated altitude. And as far as we are concerned at the moment, we are just trying to look into the conversion between this true altitude and the indicated altitude. I'm sure when you go through your math sessions, you will have a better clarity on this because there we are studying just about this. All right? Yes. Now, let's look at a question. If the indicated altitude is 20,000 feet, indicated altitude is the altitude which the pilot sees on his altimeter, or for that matter any indicated value is what the pilot reads out of the instrument. That need not be the true value, right? Same thing with indicated airspeed. What the actual speed of the aircraft related to the airflow is the true airspeed, and by the time the true airspeed reaches the pilot, it has all these errors creeping into it. That's the errors like we have instrument error, position, pressure, compressibility, density, such kind of errors will creep into it, and what he sees is the indicator airspeed. But that is fine. What I need, whatever I see, if I can relate it to the actual one, like if I need 2 and if I'm seeing 10, if I need 4, I should be seeing 12. If that relation is there, then that's fine. So that is how we work, right? Yes. So indicated altitude is 20,000 feet. Static air temperature is minus 35 degrees Celsius. Static air temperature is minus 35 degrees Celsius. Find true altitude. Find true altitude. So, I'll give you time to copy. You can just listen. So here we have indicated altitude is 20,000 feet. We have static air temperature, which is S80, is static air temperature of minus 35 degrees Celsius, for us to find the true altitude. What is the meaning of this one? Indicated altitude being 20,000 feet.
It's like flight level 200. Like whatever I'm seeing in the cockpit, on the altimeter, that shows the 20.
That's right. It need not be your flight level. It will be flight level. It will be your flight level or pressure altitude if the setting is 1013.2 hectopascal. But ultimately, whatever you see in the cockpit instrument is what is the indicated value. Therefore, the altimeter is indicated altitude, which is 20,000 feet. This is based on the pressure setting in the altimeter, right? So this is based on altimeter pressure setting. The pressure setting is 1013.2 hectopascal. Then this is going to be pressure altitude indicated as flight level, right? If it is just a local QNH, this is going to be your altitude. Right? So here your static air temperature is minus 35 degrees Celsius. You know what is static air temperature? It is the outside air temperature, the undisturbed outside air temperature, the air temperature outside the aircraft, which is undisturbed by the movement of the aircraft. When the aircraft passes through the air, because of compression, the temperature might change. But this is the temperature of the undisturbed air, right? Temperature of the undisturbed air. Now you see, we will talk about this in air temperature measurement, which is part of your instrument navigation again. We will talk about RAM air temperature, total air temperature, static air temperature. The other term for static air temperature is outside air temperature. It's commonly called as OAT, outside temperature, right? Now, you're asked to find out true altitude. Now you see, you are given indicated altitude. Why do you have to find true altitude? Is that the conditions may change. Indicated altitude is what is indicated by the altimeter, and the altimeter is always cooled for ISA conditions. And the altimeter is going to indicate to you with respect to those ISA conditions, but the actual altitude might be different. We saw in the diagram before how the indicated could be different from the true, right? One of the conditions for this change in altitude is change in temperature. So as I've told you before, we say that ISA conditions mean sea level temperature is minus 15 degrees Celsius. Plus 15 degrees Celsius, and that need not be correct. On a practical day, that can change. and that change can actually cause errors. So errors will creep into the indications in the cockpit, and therefore there could be a difference between indicator altitude and true altitude. So this difference, or this error, that is the difference between the indicated and the true, could be of two different reasons. One, it is because of change in temperature, the basic property of the atmosphere, change in temperature, or it could be because of change in pressure. Right? When I say that the aircraft is indicating 20,000 feet above a set pressure level, under ISA that pressure level could be somewhere here, but actual on that particular day that pressure level might be somewhere here. So what I think I have measured from here is actually being measured from here, which I don't realize.
Yeah.
Understood? Right? So say for example, one of the examples which I usually tell to teach, make people understand this is, if you measure my height, and if I tell you my height is like 173 centimeters, you expect that to be that measured right from my leg, which is on the floor.
Yeah.
What if I measure my height from, say, what if I stand on this table right here, but I still measure it from the floor? Sorry, if I stand on this table and I tell you that I am now 173 centimeters, you expect that 173 to be still from the floor.
Yes.
Right? There can be such kind of errors which is coming up based on your basis of measurement. Right? As I told you, you'll understand this in your met a bit later. But yes, these are two reasons why the error could come up. One is because of change in pressure and change in temperature from what? From the basic ISA conditions. Right? So we have to now correct for temperature error and pressure error, and that has to be applied to the indicator altitude to get the actual altitude. Because this became this because of these errors. So you take them out and you get the true altitude. That's what we are trying to do here. Alright? So let's think about it. What do you think is the actual the ISA temperature at this particular height of 20,000 feet? Now let's think like an aircraft. If I'm the aircraft, I am told that conditions are always ISA every single day. 15 degrees Celsius mean sea level temperature, 1013.25 hectopascal mean sea level pressure, 1225 gram per meter cube is the mean sea level density, right? Tropopause, everything, all these things, the lapse rate. I've been schooled for ISA, right? So ISA temperature at 20,000 feet, how will you find out? So the ISA temperature.
There is a lapse rate.
That's right. So it starts from 15 degrees Celsius at sea level, and every 1,000 feet you will be having a drop of 1.98 degrees Celsius, which you can take as 2 degrees Celsius also. I would still recommend you to use 1.98, but for now, ease of calculation, I'll take it as 2, right? Which is the lapse rate. Lapse rate is 2 degrees Celsius per 1,000 feet. Now, one thing which people miss out here is this is not going to be like this throughout. There's a limit for that. What is the limit?
That till troposphere, I guess.
Till tropopause. And the tropopause is ever changing throughout the earth, and therefore we take it 45 degrees north-south, which is going to be approximately 11 kilometers, or in feet, it is going to be 36090 feet. So up to 36,090 you have to can consider as lapse rate. After that, there is an assumed isothermal layer all the way up to 20,000 feet, and then we have inversion all the way up of 0.3 degrees Celsius every 1,000 feet. Right, so it's 15 degrees Celsius minus every 1,000 feet you have a drop of 2 degrees Celsius. Therefore, over 20,000 feet, it is going to be 2 into 20, which is basically 20,000 divided by 1,000.
1,000.
Right? So how much is this? 50 minus 40.
Yeah.
Right? And that's going to be minus 25 degrees Celsius.
25 degrees Celsius.
Do you understand this? This is what I'm the aircraft. I'm thinking like an aircraft. This is what I think. The temperature at 20,000 feet is minus 25 degrees Celsius. Now with this thought, I'm going to fly, and what I understand is at 20,000 feet, the actual temperature which I experience is 10 degrees Celsius colder than what I'm told. So I'm told it is minus 25 degrees Celsius. What I'm getting is minus 35 degrees Celsius. So I'm now going to have an error in myself because of this 10 degrees Celsius temperature. Make sense? So to understand that, or to help the aircraft kind of understand this, we have devised a term which is called as ISA deviation, which talks about how far the actual conditions have deviated from the ISA value. This is the ISA value. This is the actual value, static air temperature. So let's find that out. So I'm telling you from the bottom level all the way. You necessarily don't require this to answer this question. You have an equation, you can just put that through and then you can find out. But this is what we are trying to do. ISA deviation. What is the equation for ISA deviation? You're trying to find out how much is the actual atmosphere different from ISA. Therefore, the actual has to come first. So any given value, this temperature here, this could be for pressure also. But it's temperature here, so it's T actual minus T ISA. Now, one thing to keep in mind is do not reverse this. So always think about it. I'm trying to find out how much is the actual different from ISA. Therefore, it's T ISA minus T actual. T actual minus T ISA. Therefore, what is ISA deviation? What is the actual temperature?
Minus 35 degrees.
Well, the static air temperature is what is called as the actual temperature. Which is, now pay very special attention to this sign here, minus 35 degrees Celsius. Now we have a minus here.
Minus.
Right? Now what is TISA, which again has a minus. Right? So this is again minus 25. So I'm trying to emphasize those places where I generally find mistakes coming up. Because if you don't consider this, the value is entirely different. Right? So what is this? This is a minus 10 degrees Celsius. This is what we just said. This minus 10 degrees Celsius indicates that the actual temperature is 10 degrees Celsius and minus indicates a colder scenario. So actual temperature is 10 degrees Celsius colder than the ISA. That is the meaning of that. So the actual temperature is 10 degrees Celsius colder than ISA. Is that part clear? And this is the reason for one of the reasons for the error. Right? So how we cater for this is that you see the error is because of this 10 degrees Celsius temperature difference between the actual value and the ISA value. Right? So the error or the altimeter correction, which is called as the alticore or the altimeter correction, which I just told you before, between TA and IA, is equal to, you provide a 4 feet correction for every 1000 feet. For every 1000 feet, there's a 4 feet correction that is provided. I'll tell you this from where this kind of value is coming up as a derivation later. When we talk about the same thing in instrument now, I'll explain that to you. But as of now, you can think that for every 1000 feet, there is a pressure correction of 4 feet that is given. The correction is 4 feet. Now, so pressure correction is now accommodated here. Now we have a temperature correction because of 10 degrees Celsius change that has to be accommodated. What is this 10 degrees Celsius change? That is the ISA deviation. So for every ISA deviation is the correction.
Okay.
So think about let's understand this equation with respect to this particular question here. Altimeter correction, also called as alticore, is for every 1000 feet there's a correction of 4 feet. Now one thing which you have to understand here is this 1000 feet is with respect to the height based on pressure setting on the altimeter. Based on the pressure setting on the altimeter, whatever vertical distance the aircraft is showing, it is per 1000 feet of that. So based on the pressure setting on the altimeter, what is the vertical distance shown on the aircraft? That is not the true altitude. What is shown on the aircraft is the indicator altitude, which is 20,000 feet. So per 1000 feet of 20,000 feet is 4 feet into 20. For every 1000 feet you provide 4 feet correction. For 20,000 feet it is 80 feet. Right? You multiply that with, this is for 80 feet is for 1 degree Celsius of ISA deviation. Per ISA deviation. We have 10 degrees Celsius of ISA deviation. As far as deviation is concerned, the negative value is not a concern for us. So therefore, here this is for every IS degree Celsius of IS deviation. For 10 degrees Celsius is going to be into 10.
10.
Right? So how much is this?
800.
800 feet is going to be the error between indicated and true. Or indicator and true is going to be different by 800 feet. Right? Which is not extremely off here. That is because the deviation is only 10 degrees Celsius. If the deviation would have been much more, this will increase more than that. Right? And now let's see which one is greater and which one is less. Is true more than indicated by 800 feet, or is indicated more than true by 800 feet? Now you look at this particular scenario, what is the aircraft expecting here? The aircraft is expecting here to be warmer.
Minus 25.
Which is warmer,
Yeah, warmer.
right, than the actual scenario. The actual scenario is colder here, minus 35. So the aircraft is expecting a higher temperature, which is warmer, but the aircraft eventually ended up into a colder scenario, expecting minus 25. You close your eyes and you think it's minus 25. All of a sudden you get minus 35. You experience coldness, so there's a coolness, right? Therefore, what is the case here? You are moving from a high to low. It's going to be H.
HLH.
What's the meaning of that?
Our indicated altitude will be higher than the true altitude.
That's what H stands for overreading. Overreading of the instrument. Altimeter means indicated altitude is more than true altitude. Now this is a dangerous scenario. The aircraft is telling you you're higher. You're telling you to an altitude that is actually higher than the true. So in this scenario, you can see that the indicated altitude is going to be 800 feet higher than the actual altitude. Right? Therefore, if the indicator is 20,000 feet, what is the true altitude?
It is 19,200.
So it's basically indicated minus 800, which is 20,000 minus 800. How much is that? 19,000.
19,200.
So you are 19,200 feet above mean sea level, but the aircraft thinks, and hence it shows you that you are at 20,000 feet.